Okay, so I figured I'd take a quick whack at this. There's been a couple people who've asked now about why an Elite 2500 or basically any Haltech ECU, why it won't work with being a full standalone on a 2013 plus Genesis coupe. And so I thought I'd hopefully give a quick and clear explanation as to why that's the case. So you guys know that you have a high pressure fuel pump. Okay, you're a GDI car. Your high pressure fuel pump is being driven by a lobe on your camshaft. Okay, so there's a physical constraint between the displacement of this pump and the position of your engine. Okay, so just keep that in mind. I'll come back to that in just a minute. You also have a fuel pump in your fuel tank, and that is constantly pumping, and it's trying to fill the high pressure fuel pump cavity. Okay, so when the piston is low, and again I'll iterate, this is a simplistic illustration, but it communicates the point. So when the piston is low, the fuel pump in your tank is able to fill this cavity, and so it fills it. And then as your engine rotates, this cam, the high point in the cam comes up, pushes this piston up, and that is the fuel that could potentially be compressed to the higher pressure needed, your high pressure rail for where your injectors are getting fed from. That's how that pressure is obtained. Also, in the connected to the high pressure pump cavity is basically an outlet valve, and this is a solenoid valve. It's controlled by the ECU, and it just basically controls what volume of fuel actually gets compressed to the high pressure. Okay, and the way it does that is it's open. Okay, it's always open unless the ECU shuts it. So let's just imagine for a minute the piston is low, like it's shown here. We have completely filled this volume with fuel from the pump that's in our fuel tank, and then as this cam lobe is coming around, this piston moves up, it shuts off. Okay, so it'll be higher than this inlet port. And with this valve open, it will just take all of the fuel that's in there and pump it right back out to the inlet side. Well, that's not going to do any good because we didn't actually compress any of that fuel to the high pressure needed for the direct injectors. So what happens is, again, we fill this cavity up, the cam lobe comes around, we start moving past this inlet port. And then at a certain time, okay, let's just say this face moves up to here. At a certain time, the ECU will shut this valve so that fuel can't flow out anymore. So this gets shut, and this amount of fuel is taken to high pressure because there's nothing else that can happen. The cam lobe says you will go up, and so that's what happens. This fuel pressure increases pretty rapidly, and that is what feeds your high pressure injectors. So the reason why this ECU won't work as a standalone on this car, or the GDI car, is because it does not implement this control strategy. There's no way to set up tables in the ECU to take control of this system. We've got to look at the high pressure rail pressure with a pressure transducer. Okay, so the ECU gets that. That's not a problem for the Haltech. You can do that. The problem comes in with control of the solenoid valve with respect to engine speed and position. So the engine speed, so how quickly basically is this cam lobe going around, and then at any point in time, what position is it in? So we're going to have a certain amount of fuel that's required to meet a target air-fuel ratio at any given point in the operating range of the engine, both engine RPM and manifold pressure, right? There's a map for that. At any given point, because we have characterized our system, there is a known amount of fuel that's required to meet that target air-fuel ratio. And so the ECU is going to implement that by opening and controlling this valve based on engine speed and position. And so when I say position, we actually need to know the position of this cam lobe, and we need to know it very quickly and very often. So there may be a processing power issue with the Elite 2500. Maybe it cannot process those calculations quick enough. That's a possibility. I don't know for sure, and so I can't really speak to that in a for sure way. But you do need to know the position of this cam lobe. You need to know the displacement of your high pressure pump, and you use those things in a calculation to determine when to shut this valve so that you can take the appropriate volume of fuel to the high pressure needed for the injectors. And that's a very that's a calculation that, again, like I said, happens very quickly. It has to happen very quickly, and it's not just a typical PID control strategy for this solenoid valve. It can't be, because it has to be related to the position of the engine in order to open and close it at the right point in time in the stroke of your high pressure pump. So anyway, that's why. So I thought I'd show you just for a second here. This is the Motec GPR DI package, and so these are some of the parameters that they require in order to run the engine. And so I have it filtered here based on fuel pressure, direct bank 1 pump. And so these are all of the pump parameters that they want you to input to the ECU so that it can start calculating the things that I was speaking to before. So you'll see here, fuel pressure, direct bank 1 pump output resource. This is the resource that's going to be used to control the solenoid valve that I was talking about. This is the pump displacement, so you actually tell it what the displacement of your high pressure pump is. So that would require you to measure the diameter of the piston that's in that pump, and then also the stroke, which would be derived from the lobe, the lobe profile. What's the low and the high on that? You can get the lift out of that. Pump 1 delivery angle. So again, this comes down to knowing engine position, and basically this is going to let you set up a table that says when you want that solenoid valve to close and shut to take the volume of fuel that's in the pump to the high pressure. These are some of the things related to controlling the solenoid valve. There's a limit angle, so there's a point at which there's diminishing returns, and so that comes into characterization of the high pressure pump itself. If you're figuring out all of these things, if you're reverse engineering a car and you're figuring out these things on your own, it takes a great deal of time to measure and find these things. Here's the cam lobe details. So how many lobes do you have? You tell it that. You can tell it the pitch of the lobe. So what's, basically what's the spacing between the high points in the lobe? These are the things that it wants in order to control a DI system. So even if the Haltech's processor was fast enough, there's just not currently the tuning strategy implemented in the ECU for a tuner to take control of a direct injected engine. It's just not there. So that's why a Elite 2500 cannot run a GDI car as a full standalone. However, there is a possibility that it can be used in a piggyback type configuration where we use the factory ECU to run the DI system, and then we tap into and rob the signals that we need to hopefully take over control of fuel, throttle, or not fuel, I'm sorry, throttle and spark. Okay, so throttle control and ignition, we can hopefully take over control with the Elite 2500. And then we can do supplemental fuel on top of the GDI fueling that's happening, and do that with the Elite 2500. And so there's a possibility that that can happen. I don't have a GDI car local to me. Well, I probably do. They're just probably not willing to let me start probing their car. And it's hard to make progress on it when I don't have a car to take measurements on, and also an owner who's willing to try new things. So that's a challenge that hopefully we can find a way around. But anyway, hopefully that was kind of clear, and that's why it won't work as a direct standalone.